storm. Does the Carrington event repeat itself? In 1859, a series of large sunspots appeared on the sun, and just under a day later, massive auroras appeared all over the world. It was the prelude to the largest recorded solar storm. On September 1st, 1859, it was in the midst of the Victorian era, and not the amazing steampunk Victorian era, where goggle-wearing gentlemen and adventurous ladies soared the skies in their steam-powered brass dirigibles. It was the Victorian era of cholera and child labor. However, technology was advancing by leaps and bounds, and the first telegraph lines and electrical grids were being installed. The telegraph was like a primitive version of today's electrical grid and internet. That fateful morning, British astronomer Richard Carrington was studying the sun and was amazed by the enormous complex of sunspots that had invaded our star. So impressed was he that he made this drawing. As he observed the spots, Carrington noticed an area that was shining intensely on the surface of the sun, becoming a large, bright white kidney-shaped flare. It was an unprecedented activity. In 1 minute, the activity calmed down and faded away. 5 minutes later, auroral activity erupted across the planet, but not the auroras enjoyed by the inhabitants of Alaska, Canada, or Scandinavia. We're talking about auroras everywhere on Earth, even as far south as Cuba or Venezuela. The auroras were so bright that one could read a book at night. These beautiful auroras were just an effect of the monstrous flare. The other impact was that telegraph lines and electrical grids collapsed from the electricity passing through their cables. Operators received electric shocks from their telegraph machines, and telegraph paper caught fire. 2 telegraphers in Portland and Boston were able to talk for 2 hours with the batteries disconnected, solely powered by the energy induced by the aurora. What happened? The most powerful solar flare ever observed. A solar flare occurs because the sun's magnetic field lines can get tangled up in the solar atmosphere. At one point, the magnetic fields reorganize, releasing a large wave of particles and radiation. Flares occur in 3 stages. First, there's a burst of X-ray radiation. This is followed by the impulsive stage, where protons and electrons are accelerated off the surface of the sun. Finally, another burst of X-rays occurs as the flare fades away. Those particles released into space take several hours or a few days to reach Earth and interact with our planet's protective magnetosphere. And then we can see beautiful auroras in the sky. This geomagnetic storm causes Earth's magnetosphere to move, driving charges back and forth through cables, burning circuits, destroying satellites, and overloading electrical grids. In 1859, this caused a not too serious problem, but today our entire civilization depends on circuits and cables. They're in the hundreds of satellites flying over our heads and on which we depend for communications and navigation. Today, everything is electronic or electronics controlled. What would happen? We got a preview in March 1989 when a much smaller geomagnetic storm than that of 1859 crashed into Earth. Auroras could also be seen in Florida. Although the interconnected electrical grid of the United States and Europe felt the strain, the Canadian province of Quebec could not handle the load and went completely offline. For 12 hours in Quebec's frigid winter, almost the entire province was without electricity. And on July 23, 2012, a Carrington-class supersolar storm detached from the sun. Fortunately, it did not hit Earth. Had it done so with cell phone towers and huge high-voltage transformers, there could have been chaos. Today, satellites play an increasingly important role in our lives, from providing internet connections to allowing visitors to navigate the heart of distant cities. GPS services enable us to navigate our cars along roads we've never traveled before without a paper map. and some form of radio has become the backbone of our entertainment and communication networks. The location of satellites above Earth's atmosphere makes them particularly vulnerable to the adverse effects of space weather. But now, the world has the chance to test a Carrington-type event and its vulnerability to it. Since yesterday, powerful radiation from coronal mass ejections, CMEs, from the Sun, which space weather experts call comparable to the 1859 Carrington event, has been arriving. For now, the consequence is spectacular auroras borealis and australis around the world. But the event, which will last for a few days, has only just begun.